Welcome everybody to the channel School Online. In this video we are going to learn about how we could use the other approach of finding derivatives. In the previous video we have been learning how we could find derivative using the limit method. It is a long way, it's quite a long method, and it involves a lot of steps. But for this one, it's just based on rules, the one I'm going to show you right now, and it's actually the one that is commonly used when finding derivatives. It is based on rules. We have the sum rule, difference rule, constant rule, power rule, product rule, and rational and quotient rule. Okay, and so it is like every function has a way to find its derivative, has some rule to be followed. Once you master that rule, you could find derivatives of unlimited number of functions. Okay, so let's just get to study that too. Today in this video I'm gonna show you the sum rule and the constant rule and the power rule, all of them together, but meanwhile we're gonna take one example. So let's say we have a function y is equals to minus x squared plus 3. Okay, let's say we have a function that is y is equals to minus x squared plus 3. So how could we find its derivative without using the limit approach? So the best way to find it is to find the derivative of both terms of this equation, of this function. So it's going to be dx derivative of minus x squared plus the d all over dx of 3. So what this gives us is the derivative of, how could you find the derivative of minus x2 squared? So the way to do it is to bring these two down and multiply it with the x, with the negative x, and subtract from the power, which is 2. You have to subtract 1. So you're going to get minus 2x, and instead of having 2 at the power here, 2, here you're going to subtract 1. So when you subtract 1, you're going to get 1, right? Minus 2x power 1. So plus, you're going to say plus. So the derivative of 3 is now a constant. It's not followed by an x. It's not followed by x, so it's going to be 0. The derivative of a constant is 0, and we're going to see that in the rule, the constant rule. Okay, so okay, that's how we got the derivative, the first derivative, the y prime. So if we want to find the second prime, the second derivative, the y double prime, it's just gonna be the derivative of the first, the derivative of y prime. Okay, so it is just gonna be the derivative d all over dx of this one now, which is minus 2x. So this one is just eventually giving us minus 2x. Okay, plus 0 is not making a sense. So it's going to be just minus 2x. So the second derivative of the y double prime will be the derivative of the minus 2x. So, and the way we are going to do it is going to be obvious. Remember, this one is raised to power 1. So you will bring this 1 and multiply it with negative 2. It just remains negative 2. And then you're going to subtract 1 from the power. So it's going to be like 1 minus 1 here. 1 minus 1. You're going to subtract 1 here. Okay, so that eventually just gives you minus 2x power 0, but x power 0 is just, you don't have to write that, okay, because it's not making a signal change, so you're just gonna let it to be minus 2x. Okay, I mean minus 2, it's gonna be just minus 2. So there isn't big thing here, it's only that we are going to bring the power down and we multiply it with x, and then what? We subtract 1 from the power at the top. So let me write for you the rules here. Let us start with the power rule. So what the power rule states is this. It's saying, as if you want to find the derivative, the d all over dx of a function, let's say that function is x power n, okay? The easy way to do it is just going to be to bring that n down. So it's going to be n times x, and then you subtract from that n at the top, you can subtract 1, so it's going to be n minus 1. Okay, the same way we have done to the 2x here. Remember, here the 2x we subtracted 1 until we got this. Okay, so the power law states that this is what it states. You bring that n, you multiply it with x, and you subtract from the power, you subtract 1. Okay, so if we now write for the second rule, maybe the constant rule, what the constant rule says is, it says, assume you have a function, and that function, let's say our y is equals to some function c, okay, some function which is constant c. If you want to find its derivative, the way to do it is going to be how? It's going to be like this. So it's going to be the derivative d all over dx of a constant c is always going to give us 0. Remember, a constant is that number that's not followed by the variable that we are differentiating with respect to, okay? Like our case here with 3, or even here -2. If you want to go and find the third derivative, that is going to be y triple prime. If you want to go and find y triple prime here, it is just going to be d all over dx of -2, and since it is a constant, it's just going to be 0. Okay, so that is it. Okay, finally, let's just write something about the sum rule. So the sum rule states that if you have a function u plus v, a function that's u plus v, and you want to find the derivative d all over dx of a function u plus function v, so the easiest way to do it is going to be just the way we did. Okay, it's just going to be the way we did, which is going to be you will find the derivative d all over dx of u, and then you add it to the derivative d all over dx of v. Okay, just the way we have done with our example here. Okay, it's just a very easy way compared to the limit approach that we did in the previous 2 videos. If you didn't watch those 2 videos, you may consider watching so that you can understand how you could find the derivative using the limit approach as well. As for now, we're going to stop the video here. In the next video, I'm going to talk about derivative, how to find derivative using the difference rule. So see you there. Thank you.